Hello, in this video I will demonstrate how to perform an F-test. An F-test is used to test the difference between two variances or standard deviations. We begin with the following problem. It says a researcher is testing the claim that there is a difference in the standard deviations of the amount of time spent waiting in line to check into two airlines, Trans World Airlines and Northwest Airlines. The data is summarized below, and the units of the standard deviation is in minutes. Test a claim using alpha 0.10. So for Trans World Airlines, we have the standard deviation is 0.45, sample size is 10. Northwest Airlines standard deviation is 0.22. Sample size is 7. And we have to take note that when we're performing an F-test using our book, we require that the larger standard deviation be labeled with subscript 1. That's the case here. When we state the claim, we have to use population variances. So the claim is that variance 1 is not equal. There's a difference between variance 1 and variance 2. That's the claim. That's an H sub 1 statement. H naught is that the two variances are equal. Next, we calculate the degrees of freedom of the numerator. That's n sub 1 minus 1, so 10 minus 1 is 9. 10 minus 1, 9. Degrees of freedom of the denominator, n sub 2 is 7, so 7 minus 1 is 6. And we're looking for the critical value. Now, since the test has two tails because of the not equal to sign, we don't use the left critical values. The table that we're working with does not supply those values. So what we do is we divide alpha by 2 only for a two-tailed test, and then we use this value to look up the critical value in table H. Alpha is 0.10, so 0.10 divided by 2 is 0.05. So we now turn to table H. To look for the value. So table H has several pages, with each page has a different alpha. So we have to locate 0.05. Let's see, here we are. This is 0.05. Degrees of freedom of the numerator is the upper row. That's 9. And degrees of freedom of the denominator is this first column, 6. So we can see at the intersection of 9 and 6, we get 4.10. That's our critical value. To compute the F-test, it's the sample variance for the first set of data divided by the sample variance for the second set of data. Well, we just take 0.45, we square it, we divide by 0.22 squared. That's going to give us 4.18, rounding to 2 decimal places. We make our decision. Keep in mind we're working with the F distribution, which is asymmetrical. Critical value is 4.10. Test point falls in the critical region. Thus, we reject the null hypothesis, and we can support the claim that was being made. Thanks for watching the video.